Another example of a word problem here. This function, y equals negative 0.029x squared plus 0.59x, models the height of a frog's jump, where x is the distance from the jump start in feet. All right, so before we get started, let's think of what this jump looks like. Okay, it's quadratic, x squared. So I have an upside down parabola, upside down because my a value is negative here. So here's my little frog. Looks a lot like frog, right? Or a person, I don't know. All right, so here's my frog, and this is the path of its jump. Okay, we want to figure out how far did the frog jump. Well, let's think of what my variables represent here. So x is the distance from the jump's start in feet, and y is representing the height of our frog's jump. If I want to find how far the frog jumped, I need to find this x-intercept over here. So we could do a couple of different things here, but really what we need to think about is that I want to find when my y value is 0. I need to find when negative 0.029 x squared plus 0.59 x equals 0, which really means where is that x-intercept? Let's use our graphing calculator to find it. Okay, so I'm going to put in my function, y equals negative 0.029 x squared plus 0.59 x. And we're probably going to have to adjust our window from where we just had it with example 4a, but let's try graphing and see what we have. Okay, yeah, we definitely need to adjust this. Well, let's start off with that standard window. So zoom, standard, to get from negative 10 to 10, negative 10 to 10. And maybe this is all we need. Okay. We can kind of see how our parabola is kind of leveling off here, which means we're probably pretty close to our vertex. Let's go to our window. And I really don't really need to see any negative x values because our frog didn't jump a negative distance. So let's make this x min 0. And let's maybe try 30 as our x max. And zoom fit. Okay, and I really didn't even need to go all that far out, but we have it there anyway. Okay, how far did the frog jump? I want to find what this x-intercept is. So we go second, calc, 0. And if I'm trying to find my x-intercept here, left bound, I need to be on the left side, which I am. Right bound, let's go to the right a little bit. Here we go, looks good. And guess. So let's see, that's 20.34 feet. About 20.3 feet. And let's double check too what our other x-intercept is, just in case. Okay, second calc 0. Scroll over. And I need to be on the left side of my x-intercept, which we are here. Right bound. And guess. That is 0, 0 again. All right, so our frog jumped 20.3 feet. That's pretty good. How high did the frog jump for part B? Well, we have to find our vertex here. So we go to second calc. And since we have an upside down parabola, this is a maximum value I'm trying to find. Left bound, right bound again. We need to be on the left side of the vertex. The right side of the vertex, and we can hit enter. All right, so which one is telling us the height of the frog? That 10.17 is the horizontal distance. This 3 is our height. So 3.00, our frog jumped 3 feet. All right, reasonable domain and range for our situation. Well, our frog can't jump any farther than 20.3 feet. It can't jump a negative distance. So our domain is that x is between 0 and 20.3. And then our range, looking at our y values, well, our frog didn't jump any higher than 3 feet. It can't jump a negative height. So our range, or y value, is between 0 and 3. And I like these reasonable domain and range questions because it helps us to think not just about our parabola, but the real world meaning behind what we're modeling.